I guess let's get started. So, welcome everyone. I hope you had a good lunch. I'll try to wake you up a bit. There's some coffee outside of the room, so feel free to grab some. So my name is Michael. I'm product manager at SUSE, responsible for virtualization, containers as well. And I have Antoine. Antoine is a project manager, working on virtualization as well. And the session is kind of a introduction into what we are doing, as well as some details what we are doing when it comes to virtualization in SUSE Linux Enterprise Server, and some of the related products and offerings. If you guys have any questions during the session, feel free to raise your hand or shout or whatever. We'll try to respond, and we will have some time at the end again. All right, so let me start with what do we do in general. So virtualization, it's a key component of pretty much every product we do. So you can see it spans from SUSE Linux Enterprise Server itself to various add-ons, extensions, high availability extension, to other products building on top of SUSE Linux Enterprise Server for managing, like SUSE Manager, SUSE Cast Platform, OpenStack Cloud, storage, and pretty much everything is related to virtualization one way or another. So it's kind of how we keep what we take care of when it comes to virtualization, so that it all works in these products, and it works also for our customers. There are three key components. So it's host platform, hypervisors, and related tooling. It's all the guests which are running on top of our platform, as well as SLES running as a guest on third-party platforms, and containers. Containers is not really virtualization, but it's very much related, so that's why I keep it on this slide. But we will not dive deeper into containers here, because there are many sessions around virtualization and containers, specifically on SUSECON. There are two more things when it comes to virtualization: quality and documentation. So it's not really key like software deliverables, but it's still very important to keep this in mind, because quality is what actually makes our products fit for purpose. We make sure that we test like almost every scenario possible, at least to an extent we know what our customers and partners use, and make sure that whatever we do is, and whatever we release actually makes sense and is usable and works fine. We will have some information about what we test and how at the end of a session. And documentation obviously is necessary, so that you know, or customers know how to set it up and what to do and how to fine-tune. So we have like guides how to tune the hypervisor in order to perform the best way as possible. Let me start with the virtualization host. So we do have a hypervisor in SUSE Enterprise Server in SLES, actually two of them. So we have Zen and KVM. We have had these for quite some time. We continue doing that because we do have customers using both, and we don't really want to disrupt their environment. So our current plan is to continue supporting both hypervisors. The hypervisors are supported more or less equally, but there are some cases where it makes sense to use one or the other, and I will get to the details later. We rely a lot on our partners when it comes to support for the platforms. We do work with them on enabling new CPUs, new chipsets, new features in the platform, new instructions. So we obviously work with CPU vendors, Intel, AMD, but also with OEMs and other providers, because it's how we make sure that SLES runs perfectly on top of these platforms. Regarding architectures, you know that SLES supports 4 major architectures. It's Intel AMD, it's IBM Power, IBM Z, and ARM. We do support SLES virtualization solutions on all 4 of them, but that's actually one difference when it comes to hypervisors, because KVM is spanning all of them. So we do support KVM on all 4 architectures, and Zen is only supported on Intel AMD, at least for now. Regarding guest strategy, so it's something what we like to call perfect guest, and the aim is really to support SLES run perfectly in any third-party host environment. So obviously we support SLES on SLES, but we also support hypervisor from VMware, from Microsoft, from Oracle, Citrix, and others. We support hardware-based virtualization from IBM. Nutanix is another host platform which we do support, and obviously the cloud environments is also a host environment which we do support. Yes, please. So this is about running SUSE Enterprise Server as a guest on top of third-party hypervisors, like on third-party hosts. So, yeah. So the previous slide was the host part, like SLES underneath, and this one is SLES on top of a third-party hosts. So that's the distinction. All right, so speaking of cloud, this is just to illustrate how many cloud service providers we are working with. So we support pretty much everything out there, starting from the biggest ones like Amazon, Google, Microsoft Azure, to like some of the smaller ones, hybrid clouds, enterprise cloud environments, and all alike. So it's a lot of flexibility where you can run SUSE Enterprise Server and use the tooling to kind of manage it, and independent of the environment, whether it's virtual, whether it's physical, or whether it's cloud. Containers, this is like the sneak peek into what do we do with containers. So we do have 2 different container technologies in SUSE Enterprise Server. One is LXC, Linux containers. It's for system containers, so full-blown operating system apart from a kernel in a container. And we also have application containers where we have the Docker open source engine. And we are also bringing in the alternative tooling like Podman, Builda, and others, and Cryo, obviously. And we do support containers on top of like all architectures. Again, the support varies depending on the architecture, but the general aim is to give our customers flexibility when it comes to platform choice. And we do work with our partners also on container support. These graphs are just to illustrate the popularity of different hypervisors. So you can see that VMware, with the chart at the bottom, has been the most popular. But over time, the popularity of various hypervisors is getting closer and closer. And also Zen and KVM is becoming very close. And this is just to illustrate the trends, so it's not really scientific charts. When it comes to containers, you can see that Docker, which is when containers started to become really popular, it's been taking off. And that trend is still there. However, when it comes to containers, there is a lot of work and effort going around when it comes to orchestration, Kubernetes, and the ecosystem on top of it. But again, not going into detail here. All right, virtualization versus containers. Important to note is that both will be around. It makes sense to keep both around and maybe even to combine them. Each has its pros and cons. So if you have a lightweight workload, which you can divide into components, like microservice-based applications, it definitely makes sense to have a look at containers. On the other hand, if you have a big beast, like a database, maybe a virtual machine is the right place for that to be. And you can actually combine these. So if you are concerned, for instance, about security of containers, you can run containers in a VM, and that they have groups of containers isolated by the hardware assist technologies, one from the other. And there are actually projects which are helping to combine these two worlds together, like kata containers is one of them, but there are others like Hyper, Runway, and so on and so forth. And we will see in the future, I'm pretty sure, even more of such projects being integrated with each other. All right, I guess I'm not going into detail here. What we generally take care of when it comes to virtualization ecosystem is our products, obviously, where we take care of like the solutions which are shipped are used by our partners and customers. Platform is the base. It's kind of to illustrate that it's something what we provide is used and useful for all the other products which we ship. And partners is really something where we collaborate a lot with, so we are very important to make their solutions, their platforms enabled for use with virtualization. And customers are obviously the target use of all our efforts, so that's how you can look at the overall virtualization story. All right, let me defer to Antoine to cover some more details.
Okay, so an announcement in virtualization stack. So virtualization is moving, and there is some, they have done some choice. The idea is we are an open source company, as you know, and we follow a lot upstreams where we are going, where they are going, and we are trying also to push what we expect in terms of virtualization technology inside our product, which means that sometimes, well, most of the times, we also try to lead some changements in the virtualization stack to fill the needs of our customers. So 2 years ago, it was SUSECON, and since this SUSECON, we have released 2 new products. It was SLE12SP4, which was a consolidation product, and we have also released SLE15. On both of these products, most of the things we have integrated is, of course, new features, but a lot of bug fixes based on what we get in terms of reporting. But we are still continue for both release, I mean, CodeStream 12 and 15 to provide both hypervisor. As Michael say, we have a lot of customers using both of them, which means that there is no reason for us to choose or to just drop one of them. And both of them provide different kind of approach in terms of virtualization. We will see that. And we also expect that virtualization will work everywhere, which means that Michael speak about perfect guest. It's clearly something really important for us. Be sure that we will be able to handle any kind of operating system running in our hypervisor, and SLES also will be something that can run in any kind of third-party hypervisor. So we have a full scope of support for that. In SLE15GS, so the latest release, we have introduced a lot of new features. And TP is what we call technology preview. Technology preview is something we provide in our product just to test and see if customer need it, and if it's something we can support, if it's something this is usable or not. So it's something we provide for experimentation, I would say. And most of the time, something in TP will come into support statement in the future if it's stable enough, it provides what a customer expects. So for 15, we have provided virtual GPU, so it's a way to get a kind of 3D acceleration and better performance inside the guest. But we also provide secure encryption virtualization from AMD. So AMD has worked on their CPU to be able to cover security issues. So you have seen that recently there is some CPU problems, and we need to address that. And there is different approach. AMD approach is to say, Okay, we can probably isolate guests each other, creating a key for each guest, and each access to this guest will use only one key, which means that any guest cannot access the other one because they have a specific key which encrypts the guest. So it's SIV. But there is also encryption of the memory. It's SEM. So it's encrypting memory of the host. So you cannot access some part of the memory if you don't have the key. And there is also a support statement of the state of the guest, which is called SIVIS. And with this technology, when you shut down a guest, the CPU register is encrypted. So there is no way to get some leakage from the CPU register to the hypervisor. So there is a full isolation. So this is a good approach to provide security on top of guest, and be sure that any kind of guest running on the system will not leak any kind of information to other guests. So we have worked also on documentation on this with AMD. So there is a dedicated documentation how to test that for you and see how can you use it. One things also we provide is QEMU guest agents for Xen. So previously it was only provided for KVM. So now there is a way to use that inside guest. There is guestfs tools. Guestfs tools is a kind of tool stacks that give you a lot of power to manage your VMs. So you can do a lot of stuff like being able to rescue VM or customize your VMs or clone VMs, whatever. And we have created a new tools, which is a virtbuilder repository. So with virtbuilder, you can access a kind of index which lists a lot of VMs available. So it could be any kind of VMs, SLES, Fedora, Leap, etc. And then you grab it, you copy it, and then you do the modification, and then you run this VM. So virtbuilder provides you an easy way to access VMs, any kind of VMs, and do some stuff on it. And now we provide a way to create your own index, which means that if you create your own VMs and you would like to get an index repository to be able to use it, you can do that with this tool. So after that, there is a lot of fix in the tool, classical stuff. And we have also integrated new support for VMware, for example. So now we support encrypted guest from VMware. And GOS, so GOS is what we call just enough operating system. It's a really small system you can use based on SLES. And now it supports on top of our virtualization stack. So if you would like to see some demonstration about virtbuilder, GOS, or whatever, so we have a stand at the technology showcase. So just go down, ask some question, and we can show you some stuff around this. So Xen. Xen is a technology which is different because it deals with what we call privileged domains and unprivileged domains. Privileged domains, it's DOM-O, and DOM-O is the main hypervisor. DOM-U is unprivileged domain, and there is restriction to use it. One of the main goals of Xen currently, based on the lot of security issues that occur recently, is to try to secure as much as possible the usage of VMs, okay? And they have created what they call PVH v2, which is another kind of para-virtualized guest. So you have two kinds of VMs you can run. So full virtualization, so you emulate everything, and PV guest, which is para-virtualization get, which needs a modification of the OS to be able to run on top of the hypervisor. And PVH v2 is currently has been working by Xen community and us to provide as much as possible a light HVM guest, which means that it will be a PV guest which will not use any kind of emulation. So it will rely only on hardware virtualization extension, like VTD or IOMU on AMD. And as it's not doing any kind of emulation, so you just modify the system to be able to run this kind of VMs, so you remove a lot of problem or code, because qemu is around 1 million and 5,000 line of code. So if you remove this code, then you remove a lot of problem in terms of security. So your footprint in terms of surface attack has been reduced. So you provide better security. Xen is also working with Intel also to be able to provide better support of CPU flags. And one of the CPU flag was L2 cache and cache allocation table. And now there is a way, if you have that kind of technology, to be able to split it and share it among the guests, which means that you can decide how you will use your L2 cache inside the guest. So I speak already about AMD SIV, so Xen supports that. There is 4 kind of scheduler available in Xen. So Credit One, which was the former one. So it's lightwave. It's based on the weight of the guest. So which means that if you require a lot of CPU, then a guest require a lot of CPU usage, then the power will put on this guest. And Credit 2 is on top of this. It's a new scheduler. Well, it's a new generation, but which take into account also latency, which means that it's Credit 1 plus latency. And there is 2 others, which I did not name, for real-time, RTDS and Arkin 653, which is for automotive, real-time, and stuff like this. So you can choose the scheduler you will use to improve and tune your usage of your VMs. A technology preview, it's DM restricts. What's DM restricts? It's a device model restriction. And as I told already, we've got a lot of problem because when you are doing emulation, you expose a lot of codes, which is probably unsafe in some parts. And using DMOP, so device model operation hypervisor, you can decide what kind of stuff you will be able to do with your device model emulate inside the guest. So there is a lot of work on this area to be able to restrict and be able to confine the usage of your device model, so any kind of device inside your guest. PV calls driver in Linux. So currently, if you would like to get access to specific PV drivers, it was only on the hypervisor side. Now we are working to get this in the Linux. So it will be a way to expose POSIX request across the guest, which means that it will be faster, and this removes some parts of the work done by the hypervisor. On VMI improvements, so VMI is something to, it's a virtual machine introspection, and it's also security stuff. It's something that restricts the usage of memory. So it do an audit of the memory of the guest and restricts the usage if it thinks that's a sensitive access memory, some sensitive access has been done in some sensitive memory. So it will shut down and restrict the access. So you can see that Xen is, well, since 4.10, they are working on getting a more secure hypervisor. So increasing security, so XPTI, so you know PTI, page tab isolation done by the kernel, KPTI. XPTI is the same for Xen. So you isolate the user space you will expose inside the guest. And branch predictor hardening, this means that due to the complexity of all the security issues we've got currently, so you have a Spectre, Peldon, L1TF, etc., there is a lot of scenario possible. And it's clearly complex to decide which mitigation you would like to do on top of this security. So Xen has integrated something that will decide for you based on your kernel version, your hypervisor version, your microcode for your CPU, etc., etc. And based on that, it will decide what kind of security you should run and enable some combination of mitigation to avoid any problem of security inside your guest. PVH, so I already discussed about that, but PVH DOM-O is something new they are working on. It's not yet supported. It's TP. And the thing is, we would like to reduce as much as possible the footprint, the exposition of device model inside a guest. But if we do that also on top of the DOM0, so the privileged domain, then you will have a smaller hypervisor, which means that the security will be better. PCI config space emulation in Xen is something which deals that you don't have to deal with the kernel, but the hypervisor will deal with everything dealing with PCI configuration. So you don't need anymore to do qemu stuff and deal with device model exposition using qemu, so for everything like FV. But Xen will do the stuff. And that's again something for the security, which means that based on what we provide with qemu currently, if you take qemu and you just extract what you just need to be able to do PCI config, then you don't expose all the code you will have through qemu. And so the footprint of what you will do inside Xen and guest will be smaller, so you have more security. Scheduler optimization, I'll already speak about that. So credit 2 is something, is one of the scheduler, and now it supports CPU affinity. So you can bind a CPU to a specific VM, and it also supports cap. Cap stuff is something that's saying that even if you have got some CPU which are in ideal mode, you can restrict the access and say, even if there is CPU available, don't use it. And of course, there is some improvement in supporting more CPU instruction, so it's always work in progress. KVM QEMU. So it's a bit the same. I mean, in QEMU, for example, we are trying to improve performance. So one of the problem we've got is always performance when you do emulation. And if you can provide a new way to do translation look-aside buffer, so which means that you have a VM guest under pressure, if you improve TLB, you will improve the performance. So there is a lot of work on this. There is also a new way of expose NUMA CPU for the guest. QCO2, so it's one of the image formats currently mostly used by virtual machine image. Now we support LUX encryption format, which means that yeah, you can access encrypted guest image. There is progress in migration. So return path. So one of the problems of migration, when you do migration from one host of a virtual machine to another host, one of the problems is getting the status of the migration. And sometimes you didn't get the status from the destination host. And return path is something that takes care about this. And if there is no information from the destination host when the transaction, the migration will be finished, then it declares that the destination host is no more accessible, so it will fail over and get back to the source host, and you will be able to continue to use your VMs. What else? Oh, yeah. Something really important is now in QEMU, every usage of VMs is locked, which means that your image will be locked, which means that there is no way to use the same image for different guests until you declare that you would like to do so. And it's a major change because sometimes you would like to share some devices and it will not be permitted anymore. And you will have something saying that it's not possible. So there is some parameter to be able to tune that. Sorry. QEMU image resize, so pre-allocation. Pre-allocation of disk image is something that you can use to speed up the growth of an image. So for example, qco2 is something that in qco2 image, when you create your image to store your VMs, it's small until there is data inside. And if your image grow, or your system grow very quickly because you put a lot of data in it, if you don't do pre-allocation, it will slow down the usage of your guest. So you can do pre-allocation of 0 data inside, and then it will speed up the usage of your VMs. There is also various fixes in different kind of architecture. We support more vCPU for Windows guest. There is also improvements in getting information from disk. And we can also shrink qco2. qco2 is something that's it's not big, but if you can shrink it, it could be useful to get a less footprint of your image size inside the system. Yeah, so I speak a lot in QEMU3. So currently there is QEMU4, but in QEMU3, a lot of progress has been done in migration. And migration is a key point if you would like to keep your infrastructure on, and if you are providing services. And now there is some parameters to be able to deal with bandwidth when you are doing a migration from one guest to another, from one guest on one host to another one. You have a recovery post-copy migration, which could be useful in case of failure. You can recovery your redo again your migration, and it will recover the data already sent and try to restart from this point. So you can save sometimes, and you can also do some kind of pause. So if you need to just pause because you would like to do some change or whatever, it's possible in migration. libvirt. libvirt is the tool stack we recommend to use at SUSE. Why? Because we think that launching directly QEMU command line or dealing with Xen with XL, libxl tool stack is not a good idea, especially because you will learn some things and can move in the futures. libvirt is a kind of wrapper to deal with virtual machine, which means that if you know how to use libvirt, you will be able to handle any kind of hypervisor. So we really push people to use only libvirt for that. In libvirt, that's the same. libvirt evolve with QEMU, KVM, and Xen, which means that each time we implement something new or we get a new QEMU or Xen, we are trying to get this integrated in libvirt so you can use it. So that's why there is so much changement. So like, yeah, being able to set multi-queue for virtual block, so which means that if you have your system, your blocks devices under pressure, there is a way to say that you can use more than one queue to speed up the usage. We have seen that NUMA is better there is a better support in Xen now. So it has been implemented, and there is also the bash completion, which arrived in libvirt, which is nice. It helps you to deal with command line and stuff like this. Yeah, so architecture, I will let you go for this.
Okay.
Michael, any question, maybe?
Questions so far?
Okay.
Anybody still awake? Kind of. All right, so with architectures, it's actually pretty easy. So we support all 4 of them. So when it comes to Xen, we focus on Intel AMD, but KVM is supported on all 4 architectures. So we continuously do the improvements, like we are adding support for new instructions. And one notable difference is that power is still technology preview. We are kind of working with IBM on that one, but everything else is fully supported. So you can run KVM on ARM64, you can run KVM on IBM Z series, and obviously Intel platforms are fully supported as well. So what's supported? Here's a list of officially supported guests. So by default, we don't really limit what our customers run on top of our hypervisors, but we do focus on a specific set so that we can assure a certain level of quality, and we also do test these combinations. So when it comes to SLES, we support all our releases ranging from 11 to 12 to 15. All generally supported service packs are supported, and also long-term support is covered as well. We do support SUSE Linux Enterprise Desktop, but where it's only the latest release, mainly to keep up with all the various hardware changes which might be relevant. And it's also considered tech preview, because with hardware we are connecting to desktop, it can be sometimes pretty tricky to get it fully supported, all those barcode readers and stuff like that. But we do have a couple of customers actually using it. We do support guests from our friends delivering the open enterprise servers for Micro Focus. We also support Red Hat Enterprise Linux if the customer wants to run that as a heterogeneous environment. We don't really prevent it in any way. We also support Microsoft Windows guests, so we have a collaboration agreement that covers mainly the server releases. So we support all those which are covered by Microsoft at the moment, including the latest one, 2019. We also support the client Microsoft Windows releases, but those are not officially supported by Microsoft to be virtualized on top of Linux. So it's kind of best effort, but still, if someone wants to run them, we will support these guys as well. Notable mention here is Virtual Machine Driver Pack. It's a set of per-virtualized drivers for Windows, so that Windows VM can run as a guest on top of SLES. We do kind of refresh it every once in a while. It's fully vehicle certified, so you can install it very easily, certified by Microsoft. And we do keep adding features and changes there. So recently we added support for Windows Server 2019, new random generator driver, and a bunch of other updates and fixes. So it's like separate product, but for virtualizing Windows on top of Linux, it's pretty much a must-have. Yes, please. Yeah. Best effort, but still, if someone wants to collaboration agreement for these guys as well. Specs are some. Here is virtual. So long-term support. It's a set of per-virtualized drivers for Windows. So
VMDP is not. Yeah. So VMDP is not dealing with the host. Yeah. So you. Yes. No. So the question is dealing with support of VMDP on top of SLE12 SP2 or SP3. That's it?
Yes, because I only saw.
Yeah, in the documentation.
Where I saw to SP1 and SP2. I didn't see for SP3 or SP2.
Yeah. So just one thing. So VMDP is something you install inside the guest, so inside the Windows. Okay. So it has nothing to deal with the host. So the host could be a SLE12 SP2, SP4, SLE12 SLE15, etc., etc. So VMDP is PV driver we install inside the guest to get better performance or more support of bandwidth, so native support, for example, for GB NICs and stuff like this. So if you have VMDP, it just needs to be installed inside the Windows guest, but you can have any kind of host, hypervisor, I would say.
Because I had problems.
Okay. So on which version of VMDPO? We can discuss that later.
And a bunch of our updates and fixes. So it's like a separate product, but for virtualizing.
SLE12 SP4, but which version of VMDPO? We can discuss that later. That's okay. Okay, fine? Okay. Thanks.
Cool. All right, so let me move on. Perfect guest, we have actually discussed that. So here's a list of supported hosts, meaning environments where SLES as a guest, as a virtual machine, would run in a supported fashion. And again, obviously, we do support running SLES on our own hosts, but also we support SLES on VMware vSphere. The latest 2 versions are generally certified and tested by VMware as well. Microsoft Windows Server releases, but also others. So Citrix Zen Server is supported. Oracle VM is also supported, tested, and some others. So like recently added, it's not really here. It's Nutanix AHV and a bunch of others. Again, we don't limit by default where you run SLES as a guest, but we want to focus our testing efforts on the major platforms and give some guidance what's actually supported. So if you guys would have some other environment which you would like us to support, let us know and we can have a look. Regarding VMware, we actually work with VMware pretty closely. So if there is an issue when running SLES on top of VMware hypervisor, it doesn't really matter where the customer reports it, whether to us or to them. We work jointly on fixing the issue and fixing the respective part in there. We include the latest version of OpenVM tools right in the distribution in the OS. So there is no need to install anything on top of install anything inside SLES anymore, as it used to be the case with VMware tools, the proprietary ones. This is all open source, fully supported by VMware, and we do include it. And we actually update them every once in a while to keep up with upstream releases, to include enablement for latest vSphere features and include bug fixes. And similar setup, the very same setup we have with Microsoft. So in case someone is running SLES on top of Hyper-V, or actually Azure as well, which is based on Hyper-V, we have, again, similar collaboration agreement. So we have everything what's needed to run SLES virtualized on top of Azure and Hyper-V in there, and work with Microsoft in case there is an issue. And regarding Azure, we in fact collaborate quite a lot on delivering or enabling our products on Microsoft Azure. We keep our images up to date. We have our updated infrastructure in there, so it's a lot going on. And one thing to point out here is also WSL, which stands for Windows Subsystem for Linux. It's not really virtualization. It's kind of running Linux software somewhat natively on top of Windows. So Windows somehow emulates the Linux environment and allows running of Linux programs there. We do support it as well. We have images for both SLES and OpenSUSE Microsoft Store, so you can easily just click and install OpenSUSE image and run it directly on Windows Server. And these are to illustrate the limits which we support for various combinations of CPUs and memory. So for KVM, you can see that maximal amount of CPUs is 8,000 and 64 terabytes of memory. So this is maximum configuration. Obviously, it depends a lot on the underlying hardware. So we do work with our partners to test these combinations, and especially the high memory combinations are relevant for workloads like SAP. So they often get tested in specific scenarios. Per VM, limits is 288 vCPUs and 40 terabytes of memory for one single VM. For Zen, the limits are lower, mainly because the use cases we have had so far we're just fine using these limits. We've been working with some of the vendors. Actually, per VM limits are wrong here. We have increased that recently, mainly for the SAP environment again. And a bit of an outlook what we are currently working on. So we have SLES 15 SP1 in the works. So it's currently like almost done. We do have both hypervisors there. We did add a bunch of enablement for new chipsets, new hardware, new CPUs, and performance enablement of PVOps kernel, some security features also, as Antoine mentioned, to address some of those recent leaks in the Intel CPUs and others. And we are updating the tools and libvirt and qemu as needed to support this hardware enablement. We try to do that with every service pack, but only to an extent so that we don't break the currently running environments. So that way we keep adding new features and fixes, but still remain, the environment remains functional. And we are actually working on enabling VM management in SUSE Manager. So this has been a feature which a bunch of folks have asked for. So it's something we are currently, we are almost there. It's a very simple, easy to use web-based VM management. It will be part of SUSE Manager. We don't have it yet, so it's nothing we can announce, but we are working on it and it should be available pretty soon. And yeah. libvirt and qemu as needed to support this hardware enablement. We try to do that with every service pack, but only to an extent so that we don't break the currently running SUSE Manager.
Okay, so let's talk about virtualization testing. So one of the main problems we've got is we've got two hypervisors. We are a perfect guest. We need to be supported in third-party hypervisors. And we support Windows guest, etc., etc. And this is a main problem in terms of QA. Why? Because we would like to be sure that everything will be fine when you will install a SLES or you will use the SLES on top of any kind of hypervisor. So we have worked on different kind of projects to be able to support that. And we have defined that there is 6 or 7 projects that could be 6 main features we need to support, and to be sure that each time we release a service pack, we will be able to validate that this service pack will support live migration, libvirt will be usable, you will be able to do upgrade an host from one service pack to another one and still be it will still possible to use the VM which has been created from a previous service pack. You also can still deploy guests, of course, so create new VMs. And you will be also able to update guests inside, so guest running to another service pack. So if you have a SLE12 SP3 and you would like to update SP4 on top of one of our hypervisor, it will be usable. And we provide the same kind of performance, so no regression in terms of performance. And to achieve that, we have worked on 7 different projects. And so first one is guest installation. So it's just a basic project that this project is able to deal with install guest, any kind of guest, and check that the guest is running and it's okay. Host upgrade, it's a scenario that when you have an host running a certain service pack, you update it and you are still able to get your virtualization stack working. Guest migration is being able to migrate one guest to one host to another one. So we test that also. Guest upgrade, it's a project which deals with only being able to upgrade a guest running on top of an host. So, and then there is specific features like PV USB, V2V, So convert some guest to one technology to another one, so Xen to KVM. Performance, we have a project to deal with that. And then we have a project which deals with third-party hypervisor. And if you look at all these projects, then you can combine them, which means that you can do an host upgrade, then do a guest installation, and then use the fourth project, so guest upgrade, so upgrade the guest. So doing that, you combine all these projects, and you are able to have a big matrix of testing. So to run all these projects, it takes 2 weeks. There is 170 test cases we run, so it's really long. So we have, of course, priority for each milestone. That's why we have milestone when we release products. So I really encourage you to subscribe to SLES beta testing. So you will be able to check and to test incoming products. So we have defined that, and we are still improving that now currently, because we will add another project which will deal only with a kind of libvirt usage. So it's still a work in progress. But doing that, I mean, we are able to cover most of our needs. And this stuff is covered by Jenkins testing, OpenQA testing, libvirt TCK. So we have different kind of testing, so semi-automatic and manual, and automatic, of course. I miss to put automatic. So everything dealing with OpenQA is automatic. Everything dealing with Jenkins is automatic or semi-automatic. And libvirt TCK is semi-automatic, I would say. So everything automatic is quite easy. You just push the button and you say, do that scenario. And you just wait and you get the result. We are working to put everything in automatic mode, but there is sometimes some problems to do that. So everything dealing with virtualization testing is complex due to the matrix. So we are trying to improve ourselves. So OpenQA is something we use for SLES, Jenkins also. I think there is some demo maybe in the technology showcase about OpenQA. Because it's a framework you can use also for your company if you would like to test something. So it's something really usable, and it's open. So just download it, read the doc, and go and use it. So that's mostly all. Any question about QA testing or whatever?
So OpenQA is indeed an open source project which we use for various products to test, to do automation tests. And it's also available for anyone to be used.
Yeah, Fedora is using OpenQA, for example.
So feel free, if you want to test your products, your projects, feel free to have a look. And
so for example, to test VMDP, we have some testing with OpenQA. So OpenQA is something we use for SLES, Jenkins also. I think there is some demo maybe in the technology showcase about OpenQA because it's a framework you can use also for your company if you would like to test something. So it's something really usable and it's open. So
but yeah, that's a good point.
Yeah, and it can also test now everything dealing with command line. So you say if you type a command line, the result should be that, so it matches. So it's really powerful. I mean, we are using that a lot. Everything dealing with SLES testing is based on OpenQA. So there is hundreds of testing running on top of any kind of product we release using OpenQA. So
we wanted to kind of give you a sneak peek into all the effort which we put into the testing. We actually run these tests with every for every release, for every service pack, for each of the milestones. So for each alpha, beta, release candidate, complete set of tests is run.
And of course, because of testing is take a lot of time, so we've got what we call build validation, so which means that we put priority on what we would like to expect in terms of result. So we choose, okay, we should be sure that, for example, in virtualization, we can install guest. So I mean, even if there is bug after, I mean, it will be a bug, but if you cannot install guest, we won't release the milestone because it's not filling our QA. So our product management require. So I mean, so it's always a matter of choice, QA. So, and each time you go deeper in QA, you add a lot of constraint on a lot of testing. So you need to pick up the right one, yeah.
All right, any questions? Doesn't look like. Okay, thank you very much.
Thank you.